Hi, I'm Steve. Welcome back to the Maker's Cave, and today we're going to do a little bit more shop infrastructure. We have yet another 3D printer in here. This one is by Prusa. Okay, this is our Mini. It's a pretty small build plate. You'll see that in a second. This is the unassembled kit, and when I mean unassembled, I mean unassembled. Everything. There's just all kinds of pieces in here. You'll see this when I unpack it. We build everything from the ground up. But this is supposed to be an incredible printer with some incredible detail, even though it does have a small build plate. So we're going to build it, test it out, and see how it stacks up against some of the other 3D printers. So what we're going to do is I'll put a link below to this if you want to purchase one of these. And we'll bring you guys close and give you a top down here, and we'll start taking all these pieces apart. So we're going to cut to where they're all spread out. Okay, so these are just the boxes inside the box. Now there's many pieces inside these boxes. Let me just show you here. Now there's bags and pieces and everything else in here. So now what we'll do is we're going to take all the bags out and spread them all over. Okay, so here's all the stuff laid out here. Let me give you an overhead of it. These are all the pieces that make up the assembly. We have an instruction manual right here, but we actually will not be using this because they provide online instructions. This is only for the partially assembled. As you can see right here, the partially assembled, the bed and then the arm and everything else, that all comes assembled. We have none of that. As a matter of fact, the bars for the arms right here, I think, yep, there's the bars. And over in this box here are the stepper motors and the Z or Z, the Z control rod. At least that's what I think it is. We literally have no build space on this workbench. So I think what I'm going to do is I'm going to take some of these parts and I'm going to put them over on the desk. And I took a quick look at the online instructions, and they're pretty simple. And each one of these, as you can see, is labeled. Like it says X-axis, and this one up here says X-axis and extruder. The directions will call for each one of these packages, and then I think we'll just bring them over. I'm trying to think of anything else. Here's some tools that did come with it. Comes with all the tools you'll need, the various Allen keys. Looks like a needle nose pair of pliers. They also sent some sample PLA. Here's the power supply. Here is the, I think this, I believe, is the hot end. Yes, that's the hot end. So we'll get to that. So it looks pretty daunting, but I don't think it is. I think it's just a matter of taking your time. All the packages with screws are labeled. The directions tell you what screws to get, what screws that you'll need, and the quantity and everything. So basically the first thing we do is we need to take this assembly manual, put that aside, and then what I'll do is I'll bring the notebook over to here so we can read the instructions. So the next thing you're going to see is me putting some of these parts over on the desk over there so we can actually make a workroom here. Oh, this is pretty cool. This is a Ziploc bag of spare screws that we may need along the way in case we lost anything. So hopefully I'll put these all the way over here because we won't need those.
Several days later.
I had completely rethought how I am going to be doing this video. As you notice, I'm dressed a little different. That's because it took me several days to put this together. It was not a hard assembly. It was just a long assembly because you literally did every single piece. And I recorded all that, and I started editing it, and I realized I would lose subscribers if I put all that content on one assembly of a 3D printer up, because it is just boring.
Bored now.
I mean, you're just putting screws together. You're putting lead screws in. You're putting the LCD plate on here. So what I did is, you saw all the parts spread out all over the place, what it took to put this together. So what we're going to do is, here's the little guy all assembled. So what we're going to do now is we're just going to jump to seeing how it prints. But let me tell you, as of now, right now on their website, Prusa is running a special. There's a $30 difference between getting this thing semi-assembled and in the kit form that I had. Semi-assembled basically means this arm assembly and Z assembly is separate from the heat bed. I'm sure there's a couple extra things, but you don't have to put any of the minutia together, like the little brass fittings and the screws and the nuts. I can't express to you how much you really want to get the semi-assembled system, especially if you're doing this for any kind of business, because time is money. This just takes too long to put together. It's a fun build. I did have fun putting it together, but it is long. Like I said, there's just no way I can edit it to make it look fun for you guys, which is what I want to do. I don't want to bog you down. If you have specific questions about certain features of this during the build, like how did this fit or how did that fit, please leave a comment below and I'll answer you. But like I said, I think we're just going to jump right into seeing how this thing prints. Before we jump right into showing you how this prints, I forgot to tell you, I did have one problem in the assembly of this, and that was with the filament sensor, which goes onto here. I couldn't assemble it correctly so that the filament could go through here. I don't know whether it's something I did, whether maybe the part is a mismatch, didn't come out quite right when they 3D printed this, because they, other than the extrusion and some other parts, they actually 3D print all the parts for this. It's in-house. It's pretty cool. But I couldn't get the filament sensor to work. This is optional. You don't need it. Although I do want to get it to work, because I like to be able to tell when the filament runs out when I'm doing a print. So I'm just going to contact Prusa, see what they have to say. Maybe they can send me another one and I can put it back in there. So that was Bill. That's the only problem I ever had. As I just stated in the previous clip, I already have the machine assembled. So what I'm going to do is I'm going to walk you through everything you would have to do after the machine is assembled. Basically, that's going to be updating the firmware, setting the print head height. There is some sort of an auto leveling on this, but it's like a two-step process. So I'm going to walk you through that. And I think that's all you really need to do before we can start the print. So let's go ahead and do that. We'll start off with updating the firmware. So updating the firmware for your Prusa Mini that you just built is pretty easy. You just simply pull up the Prusa website. You're going to go to Software. You're going to go to Drivers and Firmware. So over here to the right, you're going to come down and pick the Prusa Mini that you have, and you want to do the firmware. You're going to click Download. It's going to ask you where you would like to put that. I have a special folder under Downloads just for this. Click Save. And once it's downloaded, you're going to go to that folder. And it's going to be a zip file. So you're just going to extract all the files. I created a folder for it. And inside you are going to see two files that are BBF files. You're going to want to copy both of these to a USB stick. And that's what we're going to do. We're going to send it to the silver USB stick that was included with the Prusa. Once you have those files on that USB stick, you want to take that USB stick and you want to put it right into the 3D printer right here. And then all you have to do is turn the 3D printer on and it will start the process of updating the firmware. Like I said before, the minute you turn the 3D printer on, it's going to find those files out there on that USB stick, and it's going to start the process of updating the firmware. This could take several minutes. I'm going to do this on fast forward, or time lapse rather. So then it'll just end up back at the startup screen. Now that the firmware is all installed, we are going to be moving on to the auto leveling features of this machine, which I said are like a two-step process. It uses this PINDA sensor right here that the screwdriver tip is pointing at. That has to be above the nozzle of the hot end. So if yours is not, you need to loosen a retaining screw for the PINDA sensor and move it so it's above the end of the hot end nozzle. Once you have confirmed that the PINDA sensor is above the tip of the hot end nozzle, you're going to take the lead screw for the Z-axis and turn that by hand until the Y-axis arm is all the way lower down to the heat bed where the hot end nozzle is just touching the heat bed. Once you have the hot end nozzle just touching the heat bed, what you're going to want to do is lift up this PINDA sensor by loosening this nut and then placing one of the wire ties that came with all your supplies. You want to place that underneath the PINDA sensor because that'll be the right gap. Now you want to tighten that screw back up. Now that the PINDA height is set, we can turn the machine on and it'll go through a wizard to help you set it up. So I believe you push the button for your selection. Yes, we would like to continue. Telling us that the bottom bar right here has the print head and bed temperatures. Now it's running a pre-test to make sure we put everything together good or correctly. Looks like this right here is the heat bed temperature, and over here is the printhead temperature. We have movement. It is quiet. Now I'm assuming it's doing some sort of self-leveling right now, which is where that PINDA sensor that we adjusted comes into play. Or maybe not. I think it is just checking whether the X and Y and Z stepper motors are working. I will say for a little machine, the stepper motors are quite spiffy. They're pretty quick. Went off camera here, but it's going all the way up to the top. I guess it's going to check maybe a limit sensor. Now it is checking the heat. Now the heat sensors on both the heating bed and the printhead. So it looks like we passed all the tests. Now they included this black filament. Looks like it's got some metal specs in it. So we're going to load this in. If you look down in the corner right here. Or you know what? This filament looks pretty cool. I don't want to use this for a test print. So you know what I'll do is I think I'm actually going to use the PET G that we had used to set up the print spool. So what I'm doing is I'm just taking our spool right here. Now, as with any filament, you just want to get yourself a good fresh piece or end right here. So we're going to get rid of that garbage on the end, and I'm going to feed this in right here. Okay. Now I'm going to turn the knob, and that's about what my settings are for PET G. I usually do 250 at 80, but we'll see what 230 at 85 does. So I'm going to hit whoop, hold on here, let me get over here. Alright, so now I'm going to push the button right here, should I find it. It is loading the filament. It says push the filament into the extruder. Press to continue. Oh, it's waiting for the temperature to come up. I was wondering why it wasn't feeding. I didn't read the screen. Now, I know I'm going to get comments below. You should have this, you should have done that. I at no point have ever said that I'm a 3D printing expert. I just think it's really cool, and I like building them, and I like printing stuff with them. And I just thought it'd be interesting for you guys to see me go through the same process that you would be if you ordered this machine. Okay, well, it's making some noise. Oh, it's purging, which basically means it's getting rid of any filament that may have been in there already. Once the printer starts extruding plastic, adjust the nozzle height by turning the knob until the filament sticks to the print sheet. Okie dokie. Alright, here we go. What it's doing right now is its form of auto leveling. It doesn't do a precise auto leveling, but it gets it pretty darn close. I think it's also doing some alignment. Once it gets done this, it's going to print a pattern, which is where we then adjust the print head height just perfect. It's now going to print a test pattern. It's going to lay down some lines with like 90-degree turns on it, and it's going to end with printing a first layer test box, which is like a 1-inch by 1-inch box in the back. I ran this several times trying to adjust the height of the print head. As you can see, you turn the knob to change the distance between the print head and the print base for the heat bed. I turned it what I thought was enough, but I still wasn't getting real crisp lines, especially when it would make these turns for these boxes right here, or these 90-degree turns. They weren't crisp, and there was some gaps in the first layer lines when it was laying the box down. So I tried adjusting, but I just wasn't making any progress. And in a second, I'm going to explain to you exactly why I wasn't being able to tune that in quite right. Now, I've ran the leveling several times, and you know, I'm a maker, so you know, 1/1000th of an inch means something to me. But so I think I'm moving too low. Doing some research, some Google searches or whatever. So far, I'm at 0.9, and my calibration lines that you saw are coming up better, but not best. Some people are doing actually 1.3. I think I might go to 1.2. And I want to see how that works. Do a first layer calibration. Next. Now let's calibrate. Next. Yes, I want to keep it like this. Now this is going to go through. I got to print the heat bed. Everything else is going to print. Everything looks pretty good when it prints. Those individual lines, they got better as I increased the negative Z. But when it came, hold on. But when it came to printing that final box over here, it just wasn't giving me a good layer. I mean, there were gaps between the lines and everything else. Usually when you have large gaps, that means your print head's too high. So I'll take it to 1.2 and see what happens. Now, when it did it did a line here, went down, did another line like this. As I increased that negative Z, which means the head got closer to the bed, right when it would start to make the turn, it was a little bit of a downward slant. That went away. It was more of a perfect square, the more of a negative Z I got. So I'm going to go to the 1.2, and we're going to see how this does. That line looks pretty nice. This is where I had some trouble before. It didn't give a nice square. Now it does. It looks nice and square. Man, And here is where it's going to start to print that box. Much better. Much, much better. Matter of fact, I think I'm going to take this up to 3. Yup. That is much better. There are no gaps now between the lines. I think we are there at 1.3. So you know what? Let's do this. Let's print a benchy. Now they gave us some yellow PLA. That's what I'm going to use to print the benchy, because I'm pretty sure that's what the file that they gave us. I'm using their benchy file off their USB stick. So I'm going to load this up. Okay, the yellow is in there. I'm going to take the USB stick they gave us, load this in here. Now I'm going to assume now I want to choose print. Oh, there's all kinds of different stuff. So the first thing it loads in when you put the stick in is the first file, which is this one. There's a whole bunch of different things you can do. The whistle, sheep, buddy, Prusa. I think I'm going to do the benchy. Instead of doing the benchy, which takes like 2 hours to print, I end up going with the whistle because it only took 37 or 38 minutes to print. Oh, 32 minutes for the whistle. We'll pick that one. And now we're going to print. Let's see how this goes. This is a very quiet printer, I will say that. The whistle is done. So let's take this off. The first thing I'm going to look at is how this layer over here laid down, which could be a little better. I'm not blaming the file. I'm actually blaming that maybe I need to lower that Z even more. But it looks really nice. The lettering on here. Here is the whistle. Mr. Prusa's initials right there, I would assume. This is the layer that laid on the bottom. It looks nice, but as you can see, there's some gaps in the. Oh, let me get up here. There's some gaps right in here. As it printed, it could have been a little bit tighter, and I am almost positive, like I said, that is because I need to lower that Z a little bit more. This is really nice. It's nice and smooth here. There's no stringing. Well, I guess we have to give this a test. I haven't blown a whistle in ages. Oh, it works. It works. All right, before we end, I'm going to shorten this all up and edit. But I'm going to print one of our practical parts on here. I'm going to try printing, we have that PIR at motion sensor case. We sell a lot of them around Halloween. And I think I'm going to print the box. The box is always a difficult thing to print because it's got some grooves for slots. I think what I'm going to do is I'm going to go to the Prusa slicer. I'm going to load up the STL for that box. Do the right settings for PETG. We're going to load the PETG into here, and we're going to print it. And we're going to see how this little sucker does on a good practical part. Yeah, let's do that. Once I got done printing the box, I decided, why don't I print all the pieces that make up this box? So I printed the shroud, the wall, and the lid. Here are all the pieces for the test print I did for the one part that we sell. This is a motion sensor, or PIR sensor, and it goes into this box. This box consists of two holes on the side where tabs on the lid go down so you can put screws in. There is a groove in here for an interior wall that slides down into here. There's also a groove on the front here that a shroud goes on so it focuses the pickup beam of the IR. So what happens is this usually just sits right in here. Okay, the shroud, here's the shroud, that slides right in here. So far, all the pieces are fitting in it perfectly. As a matter of fact, these slots are a little wider than they usually are because I think this particular printer actually prints a little bit better. So I had made this slot really wide for the other printers to make sure the shroud always fit. After the sensor's in here, of course the wire goes in through the back here, but this wall keeps the sensor in place. And this has been another bane on some of the other printers, depending on which printer we are on. The slots are different, so I had to open up the slot right here really wide to accommodate whatever thickness, you know, the different printers gave this groove or width that it gave it. So this slides right in, no problem. So that's really good. As you can see, that focuses the beam. And usually this is printed in black, but I printed it in gray, so it's a little easier to see. Now here's the two holes on the side for the lid. Now we're going to put the lid on here. There's tabs on the side of the lid, as you can see right there. Put this in here, and as you can see, lines up perfect. The hole on the tab lines up perfect with the hole on the box on both sides for the screw. This is really incredible. Now here's the thing I really want to bring your attention to. It usually takes about, I don't know, 3 hours to print this box. The Prusa on the fast settings will print this box in 1 hour 18 minutes. That's pretty incredible. Now the next thing that's pretty incredible, let me take everything all apart. I printed the shroud, the interior wall, and the lid. All those took 38 minutes. So you add that 30, say we'll call it 40 minutes. You add that to the roughly 120, the hour and 20 seconds that it took to print the box. That's 2 hours for a complete box. Whereas before it would take us almost 5 hours on the Anycubic Viper and the Anycubic Cobra Max and the Ender 3 Pro. The only thing and you know what? On those other printers, if it said something would print in an hour, it usually took 4 hours. The Prusa, I sliced this up. It said it would take about 40 minutes. That's exactly how long it took. Same for the box. Box said it would take an hour 20 minutes, or an hour 18 minutes. It printed in about an hour 18 minutes. I contribute this to the fact of the Prusa slicer that's included with the printer, or if you can also download it straight from Prusa. They do have other models available for their slicer. I mean, you can go into slicer for Prusa. Getting ahead of myself. You can download the Prusa slicer, and instead of me doing, looking like the Addams Family with the thing. So you can go to their site. You can download the Prusa slicer, and it allows you to pick other printers besides the Mini Prusa, or any other Prusa machines. It'll Anycubic. The Ender series, it includes all those in its profiles you can pick. Now, I contribute, like I said before, that this saying it takes an hour and 20 minutes and it taking an hour and 20 minutes to print is they really know the mechanics of the particular machine they're working with and the settings that they're using. Yeah, I really like this. This is good. The quality is good. The lines are good. Right here, you might see some, right here you might see something. You might a couple different lines right there. You see little bulges or whatever. But that's also in line with this groove that I had printed in here, which is really close to the edge. So I think that's just an artifact of printing that groove. We can certainly live with that. Again, there's like a little bit of it shows up pretty substantial in the video, but when you're in front of it, it's not that bad. And again, that lines up with where I'm printing this very narrow groove right here. So I think, again, that's just an artifact of that. I can live with that. Back here, look at how smooth that is with the holes on the side. Very excellent. The bottom, there's something's going on here on the bottom. And that's the first layer print. I think, as you saw before, I think we're still playing around with that Z offset. I think I might still have to bring the Z offset closer to the print head, or to the heat bed. But otherwise, it's good. This works fine for the product. There's nothing wrong with this. It looks more hideous on video than it does in person. The other thing I want to bring to your attention are the holes right here in the tab for the lid. There's no stringing in there. The hole is absolutely perfect. All the other filament printers that I print this lid on, there's always a little bit of cleanup to do in this hole. Actually, we just muscle through it with not even have to muscle through. We just usually put the screw through it, but there is no stringing whatsoever. This is really incredible. There is some artifact you might notice on here, and that looks like that is a residual mark that I may not have cleaned all the filament off from the when we printed the box, because it lines up perfect if you put the box on here. Because I didn't clean the bed good enough on the hotbed. So I guess now it's time for you to hear what I think of this printer. Is it more expensive than my other printers? Absolutely. Do I think it does a little bit better of a job than the other printers? Out of the box, absolutely. Other than those problems we had getting the Z head close enough, getting that bed leveling done, which isn't really that bad. Just took a few minutes to do. That's the only thing you really had to do this. It printed right out of the box. Again, I'm going to say what I said before. I bought this thing completely unassembled. I mean, I literally had to do everything to assemble this machine. At the time I purchased it, it was a $100 difference. If I had to go and buy this machine again, I'm considering this is kind of used as a business machine, so time is money. I would not do that again. I would spend the extra $100 and get the semi-assembled one, which is basically this arm and this base, I think, and maybe the hotbed aren't attached, so you just screw them together, but there's no putting the brass fittings into here, and there's no attaching the back plate. I mean, we had, if you watch the videos assembling this, I'm not quite sure how much I'm going to show you because it took a while. It wasn't hard, just took a while. Yeah, I don't think there's any need for me, if I ever bought another one of these, to ever go that route. I would just spend the extra money and get it semi-assembled. Do I think it's worth the money? Again, I think it is, especially considering right out of the box, I had a custom part that I did not modify other than putting it into their slicer. I took my STL, put it into their slicer, onto the USB, and out of the printer. And as you can see, everything fits perfect. It makes a perfect end product. Pros and cons. The con is probably the size of the plate. But depending that this machine, which I have a feeling this machine was pretty much built for a print farm. You have a whole bunch of these running. So the build plate size isn't that bad because it's pretty substantial for most 3D printed parts. Unlike my Cubic Max, of course, that's a large bed. But then again, I use that for printing, heads of robots. The other con, I guess, would say is if you bought the completely unassembled one, it's a lot of, like I said, it's a lot of assembling. I wouldn't want to do it. If you want to save yourself a few bucks, right now, the only difference between this and the semi-assembled is $30. That's a no-brainer. Just get the semi-assembled. You might consider that a con, that you have to build everything from scratch on that one. It's just a matter of time. It depends on what your time is worth. I'm trying to think anything else. Nothing else really is standing out as a con on this for me. The motor, oh my God, it's super quiet. It is the quietest of all the machines that I've had here in the cave. Even Katrina came in here and said, "Is that thing running?" And I said, "Yeah, it's super quiet." That's a pro, is the quiet. Print quality is definitely a pro. A pro, even though it's not the machine, is their software, because I think they put a lot of thought into the software, and it works very well for this machine, and I think for some other machines as well. form factor, you know, I actually consider this a pro, along with the quiet stepper motors. This small footprint for, like, if you wanted to put this into a farm, I think this is just perfect, because one of the things I like is you can pretty much have your filament located in different ways to allow this to fit in. You can get this pretty close into here. Might be nice if we were able to do it sideways, but I don't know how they would do that. So this is pretty cool. This is not a bad footprint if you wanted to put, you know, a half a dozen of these into service. Let's see, what else? The overall thought of design, I think they knocked it out of the park on that one.
That's how you do it, Mom!
The LCD screen, the software is very intuitive. I mean, they put a lot of thought into the design of this machine. It works very well. Another pro that I really like also is back here. I don't know if you can see it or not, but into here there's little viewports so you can actually see what the filament's doing as it goes through the gears. That's always very helpful for loading and unloading. Trying to think. There also is a network port back here, a network port back in here. I haven't quite explored what that'll do yet, but maybe a future video. I just wanted to get this built and tested. Now the surprise factor is there. I did not think, after spending the money I spent on this, because this is like my Cobra Max, as you may review, was a pretty large printer. This printer costs more than the Cubic Max, and it only prints, what, a quarter of the volume. So it is definitely one of my most expensive machines in here. And like I said, it's worth the money. I would definitely recommend this printer for anybody starting out or anybody who's already into 3D printing. I just can't believe how well this machine prints. I've heard of their reputation. You know, if you listen to 3D Printing Nerd and some of the other ones, they all rave about Prusa. And that's why I wanted to get one of these in here. I wanted to see what's the difference between one of these and one of these other machines. Those other machines I had, the Anycubic, the Enders, they do their job perfect. I am not in any way knocking this, but there is definitely a difference between the quality of those machines and the qualities of this one when it comes out of the box. Just, you know, I've done some tweaking on the other ones to get the prints to look good. This one, these prints are just as good as after the tweaking. This one, this is literally, that's why I'm so surprised. This is literally out of the box printing an STL that I created with no problems, no stringing. On the Anycubic and the Viper, I still have a bit of a string. If I print all three of these parts, there is stringing between the parts. I've got it down to a minimum now with some tweaking and retraction and all that, but there was no stringing in this whatsoever at all. I can't believe it. I literally could take this, throw it in a box, send it to a customer. No brush up, no nothing. I mean, perfect. I'd like to get a couple more of these in here, but you know, I got to get past that through the financial board, which, you know, means my wife.
You've got 17.5% in T-bills amortized over the fiscal year.
But yeah, I am now intrigued to see what some of their other machines are like, which are supposed to be even better than a Mini Plus. Personally, I'd be happy with, like I said, a half dozen of these in the cave printing out parts. I don't know if this helped you make a decision or not. I don't know if you're assembling it yourself, whether this babbling insane nonsense that I did of assembling this thing is going to be of any help. But if you did like it, be sure to hit the like button. And if you want to see more of what we're doing, be sure to subscribe. And if you want to get notified when we have new stuff coming up, be sure to hit the bell. But and I'll put a link below to the Prusa and the filament that I was using, and anything else that any other tools that I used. I'll put that down below, and of course I'll put a link to, like I said before, right to this. So until next time, I'm Steve. Thanks for stopping by the Maker's Cave. I'll see you at the next build.